Ever get that feeling, when you're looking up at a sky full of stars and you just think, are we it? Is there nobody else out there?
Yeah,
It's like the ultimate question,
it
right?
is.
And thankfully, you guys get it, which is why you're here. You want to dig into the real science behind it all.
Absolutely.
So we're diving deep today looking at extraterrestrial life. And to help us navigate this, we've got astrophysicist Ethan Siegel with us.
Great to be here.
No sci-fi here, just cold, hard facts.
The facts are exciting enough, to be honest.
They really are. Especially now, we've got the tools, the knowledge. We're not just like throwing darts in the dark anymore. We can actually get a grip on the possibilities here.
Absolutely. We can put numbers to these probabilities now.
Exactly. And that always seems to lead to the Drake equation. Everyone brings up the Drake equation. For a while there, it felt like the be-all and end-all for, like, how many alien civilizations are out there?
Right.
Makes sense on paper, but
Yeah.
is it actually, maybe, holding us back a bit?
That's the billion-dollar question,
Yeah.
literally. I mean, when you think about the scale of what we're talking about.
Right.
But the thing is, the Drake equation, for all its, for how groundbreaking it was,
It was.
it's based on a universe that doesn't change. Like, imagine using a recipe from hundreds of years ago and expecting it to work perfectly today.
Okay.
Our understanding of the universe has evolved. We know it has a history. It had a beginning. It's changing. That changes everything.
So it's like we're trying to bake this cake, but we don't know how much flour to use or how hot the oven should be.
It's exactly.
There are some pretty vital things missing.
There are.
What are some of the big question marks that we're still struggling with?
Well, for one, the rate of star formation.
Okay.
We thought it was constant. Turns out it peaked billions of years ago,
Oh, wow.
meaning way more stars cooking up potential planets back then. And now we've got these incredible telescopes. And guess what? More planets than we ever imagined. And not just big balls of gas, but rocky planets, Earth-sized planets, hanging out in that sweet spot around their stars, the habitable zone where the temperature's just right for liquid water.
Hold on. So you're telling me the universe was basically a star factory billions of years ago, and now we've got, what, billions upon billions of planets that could, theoretically at least, support some kind of life just in our galaxy.
That's pretty mind-blowing.
Mind-blowing is an understatement. I mean, if you took all the grains of sand on all the beaches in the world,
Right.
that wouldn't even come close to the number of planets we're talking about, right?
It's a concept that's almost impossible to wrap your head around.
It really is. But, and this feels like a massive but, just because a planet could support life doesn't mean it does.
Right.
It's like, winning the lottery.
It is. It is.
Just because millions of tickets are out there?
Doesn't mean anyone's going to win
Exactly.
or that anyone has won.
And it's a thing, we call them habitable planets, but
All right.
habitable doesn't necessarily mean inhabited. So how do we bridge that gap? How do we go from habitable to inhabited? What are the chances of life actually taking hold?
That's where things get really tricky. We're talking about life emerging from non-life, which, let's be honest, we still don't fully understand.
Right.
And then on top of that life has to survive, become complex, develop intelligence. It's a chain reaction with some pretty significant unknowns at every single stage.
Billions of habitable planets. But getting from habitable to inhabited, that's like hitting the cosmic jackpot.
Yeah, potentially multiple times in a row even.
Exactly. So, like, how did it happen here? Did life on Earth just effortlessly pop into existence?
Well, it's not quite that simple. I mean, life on Earth did show up pretty early on, relatively speaking.
Okay.
But then, well, things sort of stalled out.
Balled out.
For billions of years, it was mostly single-celled organisms just hanging out.
So Earth went through this, like, super long, awkward phase where nothing much was happening. Kind of like watching paint dry, but for, like, a billion years.
Got it. It wasn't until what we call the Cambrian explosion, about 540 million years ago,
Yeah.
that things really took off. That's
Yeah.
when we see this burst of diverse and complex life.
540 million years. That still feels like an eternity ago.
It is. And even after that, even with that evolutionary growth spurt,
Good.
it still took another 500 million years for anything to evolve with enough intelligence, with the capacity to even ask the question, are we alone?
Wow. Okay. That really puts things into perspective. We tend to think of intelligence as this inevitable outcome of evolution. But what if it was just a fluke?
Right.
What if out of everything, it's just this 1 in a billion kind of thing?
It's definitely possible, even on a planet that's teeming with life. Intelligence, at least as we understand it,
Right.
could be incredibly rare.
And not just in space, right? But in time, too.
Exactly. It's a factor of both.
Like, imagine if the dinosaurs had just a few more million years.
Uh-huh.
Would we be sharing the cosmos with, like, velociraptors flying
Yeah,
spaceships?
ain't something else.
But it makes you think, right?
Yeah.
We assume that intelligent life would, like, follow a similar trajectory to our own,
Right, right.
that they'd be building spaceships, trying to make contact. What if that's not the case at all?
It's a huge assumption on our part.
Yeah. Mind blown. So, we've got billions of these planets that could be habitable, but the odds of life, intelligent life especially, are looking pretty slim. And this is where it gets even more interesting, I think. A little freaky, even. The Fermi paradox.
Ah, yeah.
The Fermi
It's a
paradox.
paradox that's fueled countless debates, late-night conversations.
Right. The universe is massive. It's ancient. So even if there's the tiniest chance of another intelligent civilization out there, shouldn't we have seen some evidence of it by now? It's had billions of years.
It's a good point, a real head-scratcher. The Fermi paradox, I think it exposes a potential flaw in how we're thinking about all of this.
Yeah.
That we're looking for life, for signs of life, but through a very specific lens, our own.
Okay, I see what you're saying.
We're looking for radio signals, for Dyson spheres, giant structures. But what if those are all just signs of a very specific type of intelligence? And maybe even a limited one at that? What if truly advanced civilizations, what if they've moved beyond those things?
So we're trapped by our own imaginations in a way, by how we define intelligence, how we think it should look and act. It's like that saying, if you judge a fish by its ability to climb a tree.
Exactly. We're the fish looking at the tree thinking that's the only measure of success, you know?
Right. There could be a whole underwater world of these advanced civilizations we can't even fathom.
Precisely.
Man, this is where I start to feel like an ant staring up at a skyscraper. It's just, I can't even grasp it, you know? What if intelligence, at least as we define it, it's just this blip in the grand scheme of the universe?
It's a humbling thought, isn't it?
It is.
Even a little frightening. And it leads us to maybe the simplest explanation for this whole Fermi paradox.
Okay, you got to tell me, what's the explanation? What's the simple answer to the Fermi paradox?
It could just be that.
Yeah.
We're alone.
Alone.
At least, you know, in our little corner of the universe.
Huh?
At least for now, it's a possibility we can't rule out.
Wow. I got to say, the idea of humanity being it in this whole vast universe, it's a lot to take in.
It is.
It's kind of chilling, but also like freeing in a way. Like if this is all we've got, if it's just us on this little blue planet, it makes it all feel even more, I don't know, precious, you know?
It really does make you appreciate what we have. It challenges us to think differently about, well, everything. Our place in the universe, our responsibility to it. If we're the only ones asking these questions, searching for meaning out there in the cosmos,
Yeah.
that's a pretty profound realization.
It really is. It means we got to keep searching, keep exploring, keep pushing the boundaries of what we know and what we think is possible. Who knows, maybe someday our search for extraterrestrial life, maybe it'll lead us to something even more incredible than we can imagine. Or maybe, just maybe, understanding ourselves, understanding our place in all of this, that's the real discovery.
I love that sense of optimistic curiosity.
Well, gotta stay optimistic. So where does this leave us? What about the folks listening at home? Have we made them feel less alone in our loneliness, or maybe just more aware of how much we don't know?
What I hope they take away from this is a sense of awe. Awe at the vastness of the universe, the sheer scale of it, and a renewed appreciation for life here on Earth.
Awe is a good word for it. And hey, who knows? Maybe somewhere out there, someone else is looking up at their own night sky, wondering the same things. The search continues, and that's a pretty amazing thought to end on, don't you think?
Absolutely.
Until next time, keep looking up.